Hey, Dave, great to have you here. If you could just give an introduction to yourself and maybe how you got involved in Odyssey.
Sure. So we first heard about Odyssey of the Mind actually living overseas. My dad worked for IBM at the time, and some of our friends were in the process of trying to get things together to go to World Finals, and they were asking for material support, probably not like monetary support, but actually physical materials for the competition that they were working on. And so when we got back to the States the next year, those friends kind of roped us in and told us, you know, kind of explained Odyssey of the Mind to us, and it seemed like a really great fit. I was in, I think, early middle school at the time, and I was a part of sort of the homeschool co-op that we were doing. So it was a very natural fit. It was people that we went to school with sort of at the time and got to know. So so it being across the school year seemed to make a lot of sense for us and involvement and just another way to spend time with the people that we enjoyed spending time with. And it was interesting, kind of come up to speed the first year. There's a lot of lingo and a lot of trying to figure out what hands-on spontaneous problem was and what a verbal spontaneous problem was, and hearing the words, when one member is stuck, the team is stuck, and all of those things. But it was just a lot of fun. It was a great opportunity um, to kind of work on something as a team for a whole year and then go present it, and sort of all of the butterflies that come along with competition day are certainly there, but you can kind of, as a team, move through that and feel like those friendships naturally deepen as a result of that. And naturally, the next fall comes around, like, all right, what problem are we going to do next year? And we, I think I started with the technical problem. Is that problem three? That problem
Problem two.
problem two? Okay. Did that one year, and then after the first year, we were just problem one. We were vehicle problem, kind of from then on, and ended up doing it, I think, every year until my junior year of high school. So those were great. Those were a great experience, and most of those years were with the same people. We'd lose a few people, have a few new people come in, but it was some of my best childhood friends are from that time period. So it was great.
That's fantastic. To jump forward, what are you up to now? What's your career? And maybe we'll connect some dots to get from those Odyssey of the Mind experiences to your career. But what are you up to now?
Right now, I work at a company called Sierra Space, and we make mechanisms for space vehicles. So we do a lot of antenna pointing mechanisms for satellites that sit in geostationary orbit, have, down to, millidegrees of pointing resolution to point right at the ground station they need to. One of the most exciting things I was involved in was designing and building motors and gearboxes for the Perseverance rover. I got my my shirt to prove it. But that was it's probably 3.5 years of my career was spent doing that, and it was just a phenomenal experience because a lot of the space mechanisms we do, people don't hear about, people don't care about. But I mean, they're on satellites like the GPS constellation or things like that, which everybody uses on their smartphone day to day. But to be able to participate in something as high profile as the Perseverance rover, the gearboxes and motors that move the robotic arm, that do the drilling on this rover, it's neat because it's called a sample caching system. So it drills a core sample, and in the old rover, it would just put dust in an analyzer, but this actually takes a core sample and hands it off to a robotic arm on the inside. And so right now, some of my coworkers are working on the Mars sample return mission, which is going to take those samples and bring them back to Earth. So that relationship with those folks at JPL has sort of naturally blossomed. If you want to talk about, you make it in OM terms, like, well, this is the next season, right? This is the next program. Um, so that's been a lot of fun to work on. So we have an office here in Durham, North Carolina. The company's based out of Colorado, but there's about 60 of us, maybe 70 of us now here in Durham, that we do everything from we receive the proposals in from customers. We put together the schedule and cost and technical solution out to that problem statement that we get. We of course request clarifications if we need, and then if we get awarded the contract, we do the design. We host customers and we build and test and deliver all out of our Durham office. So we have JPL or Johns Hopkins Applied Physics Laboratory, or Lockheed Martin or Northrop Grumman. Sort of all of those people will come to us looking for a solution to a problem that they have.
It's very impressive to have Odyssey of the Mind, problem one, vehicle problem, be the start, and then where you are right now is building vehicles on Mars, which is a really cool arc. And even it was intriguing to hear your comment about how the clarification process is still alive and well, though I'm sure your clarifications are a little bit longer, and have a little bit more back and forth besides, is it the inside or the outside of this line that
Right.
that matters. How do the problems that you faced in, let's say, problem one in designing, small or large vehicles scale as you're designing, more complex vehicles? I imagine there's similar challenges that you face with, teamwork or working with different types of materials. But in terms of the process that you go through to solve a problem, how does that process change as the problem itself becomes more complex?
That's a great question. I feel like a lot of the principles that you learn in Odyssey of the Mind hold true and scale. So we already talked about the clarification process, and that's something that when we get something in, there's an art to writing requirements. And in Odyssey of the Mind, that would be the problem statement, right? There's an art to doing that, where you want to leave the solution space open-ended. You don't want to artificially box in or prescribe a certain approach to a solution, but you have to give enough specificity to to avoid, at the end of the day, from our industry, not getting something that works in your application. And so there are lots of times where it's a challenge to know how to write good requirements. And so I guess getting back to how does it scale, there's a field within engineering called systems engineering. And if you want to take, say, the space shuttle, for example, right, there's no one person whose brain is big enough to get his or her arms all the way around the whole space shuttle system. And so there's a whole field of engineering called systems engineering, where you take a really big problem, like how do we get astronauts and cargo and payload to space and back safely, and you have this high level, what are sort of the tier one requirements? What do we want this to do? And then each one of those then goes down and gets treated out to a second tier and a third tier. And by the time all that's done, you're able to break it down into a small enough problem to where a small team of engineers, say at Sear Space, are able to go off and execute a precision pointing mechanism, that's needed to point this intent on the space shuttle. And you've defined the temperature that it needs to operate in, how much mass it's allowed to have. And at some level, you have to break it down far enough to where even on our team, that each team member has the ability to kind of own their constituent part.
The corollary that I could maybe draw is, the long-term problem at hand is, deliver a performance that impresses the judges.
Mhm.
And then within that, you have all of the different scoring components, which are similar to maybe the granular problems that you're solving. And what I've seen with most successful teams, and at least what I experienced with my team when I competed, was that most people are specializing at some level. You may have some people that are better at creating props, or some people that are better at writing scripts, or better at designing vehicles. And so everyone is agreed upon the larger mission of, we want to do well at the performance, we want to impress the judges. But then when you start defining each individual element, you say, okay, this vehicle needs to be 20 inches long by 5 inches wide, and it needs to fit in this thing, or it needs to have this propulsion system. And so, yes, it's similar. You start with a very large vision, then you get down to it. Now, the amount of levels from impress judges to build vehicle are obviously a lot bigger in your line of work, and your budget is probably also a little bit bigger than 100 some odd dollars for your
Yeah,
entire
yeah,
performance.
yep,
But no, I think it's very similar.
yeah.
Do you have any specific examples of that you can talk about a very particular problem that you worked on, and maybe a challenge that you faced on that in any of your space engineering work?
I guess going back to the Mars rover, it was it's very cold on Mars, and power is a premium there. So the mechanisms that we use generally use some sort of grease or oil lubrication, and it thickens up at cold temperatures. And so one of the requirements that we had was to operate for millions of motor revolutions at minus 70 degrees Celsius, which is really cold. And we we had a lot of available test data for a particular lubricant down to minus 40, minus 50 degrees Celsius. In this particular lubricant, there's not a whole lot of lubricants that you can use in space. In the vacuum of space, things outgas the way that, if you buy a new car, a new couch, that smell, that the new product smell is all of those volatiles sort of leaving the material. And in the vacuum of space, things not designed to be used in space will just evaporate, and it'll just empty itself. So there's a handful of greases that you can use in space, and the one we had the most experience with, we didn't have test data that said it's a great application. And so we had designed a developmental test program saying, hey, this is what we think we're going to do. We're going to go ahead and design our mechanism, our gearbox and motor around using this. And in parallel, we're going to go off and test it. And that parallel test path, we ended up locking up a bearing. I forget if it was 60% of the way through the required life. So in the world of space, we talk about we had to show that we could operate down at minus 70 degrees Celsius. Well, the rover never planned to operate really colder than minus 55 degrees. And so there's this margin built in that says, man, if you can show that you can work here, then we have every confidence that when we operate at a warmer temperature, it's going to be fine. So when we had the bearing lock up at the cold temperature, we had to figure out what are we going to do. And that was a really difficult couple of weeks because obviously our customer in this case wants us to succeed. And so there was a number of difficult meetings in several months where we said, okay, let's try a different amount of grease, or let's try a higher temperature, or let's try a different speed, and sort of taking a step back and saying, okay, what are all these things we can do? And ultimately it was somebody at JPL saying, you know what, we can take more power from other areas of the rover, and we have heaters on the motors, and you know what, we can use more heater power to get you guys warmer, because we demonstrated we can survive, we can meet the mission life requirements at a warmer temperature. And it's not that we couldn't operate at the colder temperature; it would just be less life. And so they realized, in collaboration with our testing, that an alternate solution, a warmer temperature, would get us what we needed to.
I imagine that that duct tape also wouldn't work at minus 70 degrees Celsius in
Yeah. So
space.
there's a tape called Kapton tape, which we joke about that it's the duct tape of the space industry. It's this sort of it kind of looks like a Scotch tape roll, but it's this sort of amber orange tape. So if you look at some space vehicles, you'll see a lot of that amber orange tape, in various places. So that's the duct tape.
That's I'm sure it'll work. It'll be fine. That's fantastic. I love that you have space tape.
Yeah.
That's fantastic. What you mentioned you had one or two Odyssey of the Mind challenges that are still memorable for you. What are those?
One of the things, right? Creativity is such a high aim of Odyssey of the Mind, which is such a great place to start. I think in industry, especially in space industry, what's worked in the past, is what you kind of want to use going forward. You don't want to you kind of want to test in the laboratory to make sure you have high confidence before you go out. But in one of the Odyssey of the Mind competitions, it was vehicle. I think it was a big vehicle competition. We wanted to make our own gears, and I think it was primarily driven out of a desire to be creative. But it resulted in us learning how to weld, the skill set that as middle schoolers none of us had, right? We were getting these big metal plates and these big fat bolts, and I think whoever wanted to, we had a team of 7, so maybe 4 or 5 of us were like, I want to learn how to weld, because one of our teammates' neighbors had a shop, and I think she had a old stick welder, and so we all took turns practicing and learning the basics of it. And ultimately, I don't think I was the best one, so somebody else got to do the actual welding on the vehicle. But but it was sort of a challenge to figure out what's a creative way that we can solve this problem. And part of that was learning a skill set that none of us had before, and that ultimately, just being a builder myself, led to a welding machine getting added to a Christmas list of mine at one point in time, and that becoming a skill that I developed in high school more in one of our vehicles, ultimately, that ended up winning Vernace Fusca at World Finals, had that welding component to it. It was a metal frame, and we welded a bicycle chassis and some cam arms anyway. So it ended up sort of resulting in that. And on a non-technical side, I think team dynamics was a challenge to is always a challenge, figuring out how to work in a team. I think is something that certainly in Odyssey of the Mind, but also in the rest of your career, if you are in a field that requires collaboration, you have to know how to use everybody's gifts and talents that they come to the team with in a way that benefits the team. We had a guy who was really good at violin, and figuring out a way to work that into our skit, right? I mean, we're a vehicle problem. Like, you don't have to have a violin, but it brought an element that the judges loved, and a sort of dynamic to our skit that was totally different than we're just going about this very technical task. So realizing that different people have certain gifts and desires and talents that can benefit the whole team if they're sort of given the opportunity to voice those, and they get really passionate and motivated to do well at those.
I think my first year competing, I saw your performance with that welded vehicle at
Oh, wow.
regionals.
Okay.
And I remember us at the tournament saying, okay, we need to see this other homeschooling team They're fantastic. They're really experienced. And we had done was it Envirover? Was that the problem name?
Yes, yes.
Yeah. So we had done Envirover, and I think we had either a drill or maybe even just like hand pushing the wheels, and we thought, we were all that, and we did not so great at long term. And then I remember going and seeing this, very experienced Division 3 team, and having this moment of realization of like, oh wow, like this is what we could accomplish in a few years. And it was very inspiring to see your team perform at that level. And then, by high school, we had a lot of our stuff together as well, and it was cool to have to similarly be inspiring to other younger people as they came up to our performance and said, that was really cool how you made that prop. Or even a few years after we performed for our last time, I had people coming over and saying, oh, I remember that backdrop. So it's fun to be able to see the impact that you can have long after that you're gone, in inspiring creativity, because you certainly inspired it for me and my team, which was fun.
Oh
um,
yeah, that's silly.
you
Yeah.
uh, you mentioned a little bit earlier that creativity and innovation is a little bit more sticky in your industry, or a little bit tougher, because a lot of what you're doing is risk avoidance and trying to make sure that you're avoiding failure.
Right.
Um, and so that lends itself to safer routes. Do you have any examples though of when something maybe particularly innovative or particularly creative was developed, and how you worked around that atmosphere of risk avoidance?
I think one of the silver linings in the space industry is the motto you test like you fly. And so one of the areas that we were able to apply some creativity with the Mars rover gear motors was in how we tested them on the ground. So a lot of the a lot of the mechanisms on the robotic arm um, just provide torque. So it's pretty easy to go test them in a dynamometer type of setup where, like you would test a high performance car. You go and you set it and you say, okay, what's the speed torque curve for this device? But some of the ones that did the drilling on the actual robotic head would actually have to feed the drill bit into the rock and out. So in addition to providing the torque to the drill bit, it also had to exert a force pushing the bit into the rock. And so figuring out how to create a test setup with our gear motor in a thermal chamber at minus 70 degrees Celsius, with test equipment outside the thermal chamber that is putting a torque load, so making the gear motor work hard, and also exerting a force on the end of that gear motor was a challenge. And so that's something where a lot of creative juices were spent or spilt on solving that. And um, the ability to tweak if it didn't work out quite right from day one was certainly in there. And the ability to update things as we went and found um, was certainly present. So I think there are areas, um, maybe limited areas, um, to exercise that creative side. And that's what we're trying to do now is set up sort of an R&D lab where you don't want to. I think Elon Musk has a quote that kind of goes a little bit against the Apollo 13, the failure is not an option, that failure on the ground certainly needs to be an option or you're not innovating enough. I think that's the gist of his quote. And so finding areas that maybe it's not, you certainly don't want to test it the first time when it's in space, but what can you do to push the envelope on designs on the ground, so that you do feel confident, when you put it in a design that will end up in space, that it'll work. So I think there's certainly an avenue for creativity, and then proving that out before it gets launched.
That's a good quote. And sometimes what I see is that teens will perform, and something will go wrong in their performance, and we'll ask them about it, and they'll say, oh yeah, this is the first time we've run our vehicle because we were trying to finish so many things up. um, and while it, I guess, is some risk taking, it's not very healthy risk taking if you haven't prototyped at all, or haven't practiced. And that's where there's a healthier or a safer space, like you said, to take risks when you can take them on the ground, before the big performance. And if your mechanism breaks, or if your motor runs out of batteries or whatever because you didn't think through a checklist, then you say, oh, okay, I guess I learned from that one, and I can iterate. But you're in your parents' garage, and so that's a
Yeah.
fine place for the arm to break, or or for the wood to snap in
Yeah.
some different way. Um, you've had this journey from your beginning roots of engineering, with your first welding in middle school, to a welding tool on your Christmas list, to now an accomplished engineer. What advice would you give for a junior engineer, or someone who wants to go into, especially the field of maybe mechanical engineering or space engineering? What advice would you give them as they're starting their journey?
Build something, test something, break something, learn from it. I think that would be my big encouragement. I feel like there is value to designing something on paper, but there's so much that you can learn when you actually go out to try to build that thing that you'll be surprised about, and you'll be it'll make you a better engineer, it'll make you a better designer, a better thinker, because you'll develop this toolkit of things that worked well, and those things that worked well, it could have been really well reasoned, or you could have gotten lucky. And then there'll be this toolkit of things that went poorly, and you'll have the opportunity to reflect on things that didn't go so well. There's a space mechanism symposium, and I always find it fascinating that the papers that get the highest priority for a presentation are the ones that have had failures, and those failures have been investigated. So every time you build something, every time you test something, you have an opportunity to learn. There's always encouraged like the standard life skills as well. When you come to a group or a team, of being respectful, being kind, being able to collaborate and compromise. I think those are it's the things I don't always take for granted anymore. But working in a team environment as well. It's easy as an engineer who's not, maybe relational things don't come as easily, to love being in my bubble, but realizing all these great technological achievements have come about as a result of team interaction, being open to other people having the best idea. Brainstorming is very much a part of what we do. I won't say that we do it every day, but there's certainly times where we get an unexpected failure. It's like, let's go to the whiteboard and let's talk about, either we'll brainstorm all the ways that it could have been the root cause of the failure, or we'll brainstorm, or these are all the different ways to attack it going forward. And being able to participate in that environment, being able to lean on the wisdom of those who have been doing it for 20 more years than you have, I think is beneficial. I think that's one of the things that, sort of reflecting on this, I was thinking about is, a lot of times in school projects or even on school teams, everybody's sort of at the same level of experience. Maybe nobody knows really what's going on. But when you come into a workplace, either as an intern or as a new hire graduate, you're instantly thrown into a team where you have people that are 5 years away from retirement, who've been doing this for 40 years, who you can learn from. And
Outside assistance isn't a problem.
yeah, exactly.
You can have some outside assistance, and it's going to help you.
Yeah. The new grads that we've got, that's you're gonna figure it out as you go, but you don't want to be sort of hamstrung and not able to try anything yourself, but you don't want to not ask questions and not lean on the wisdom of those around you as well. So finding the balance between being self-sufficient and self-reliant and doing your work excellently versus being dependent and, you know, a nuisance and that sort of thing. So finding some middle ground there where do as much work as you can. And then when you arrive at a place where you're not sure, go and ask and get some clarification. And outside assistance is a great.
No, it's a great point that I haven't thought about, which is it's a pretty sharp transition from uh the OM mindset of, you know, your team is, you're completely self-reliant on your knowledge and in your team's knowledge, and most of the time it's, you know, it's stuff that you haven't done before. There's a lot of first time welding, first time painting, first time you know, writing a script. And if more experienced teams, obviously, and older teams have some advantage there, and you can see it in their performances. But I think OM, going back to the idea of like a safe space or a place where you can take risks, is it's a good place to concentrate that skill, but then realize that the real world is not like this, and sometimes you do need that outside assistance. And for especially complex problems, you know, you don't want to say, okay, we're going to put a vehicle on space and we're going to start from scratch,
Right.
when there's 100 years of, you know, aerospace technology to lean on, and a lot of people have been thinking about all, you know, the problems that you've been facing, and not be afraid to lean on that experience. um, I guess one final question, which is, are there any interesting books, podcasts, YouTube channels that you would recommend, either from an engineering perspective or just from a personal perspective, that you find intriguing or useful?
It's interesting. I was thinking through this, sort of reflecting on the books that I've read over this past year.
Gonna be like an Oprah book club, and you're gonna
Yeah.
hold it up.
Yeah. So, super specific to my field is called Space Vehicle Mechanisms. This is a reference book, you know, that, yeah, I don't know, you know, a doctor may have their reference book. So, a lot of decades and decades of wisdom has been poured into that. So this, I think, is actually on Amazon. It's not cheap, but it's you know, widely available. There's another book, again, super specific to my industry, SMAD. I think it's something about space mission design. So it talks about how do you architect, you know, you want a satellite that does telecommunications, you know, what are all the considerations to design a satellite that does that? More generically, there's a book called The Perfectionists by Simon Winchester, I believe. He's a historian. It's really fascinating. It just talks about each chapter, I think, is a level, an order of magnitude more in precision, going from steam pistons, you know, back in the Industrial Revolution, to jet engines, to, you know, sort of all of in what precipitated the need for more precise devices and machines. A book called Spaceman by Mike Massimino is a biography of an astronaut. In it, it's great because it wasn't all roses. His story was fraught with struggles and overcoming failure. You know, ultimately to become an astronaut and do some great things, but you know, he had to fight for it. So it's a great book as well. And How We Got to Now. Can't remember his name. There's actually, I think, on Amazon there may be a 6-part series, but it's a book that talks about 6 innovations. What does innovation clean mean? Clean water, clean air, and sort of how that has allowed the modern world to thrive. You know, glass, sort of all these things that had, you might think, unintended consequences, but really allowed us as a civilization to really take a big leap forward. You know, not necessarily the intended route, but there were some side consequences that were very beneficial. So
Yeah. Those all seem very interesting. The first one seems very specific, but I'm sure if I open it up and took a peek, I'd be even more grateful for, things like satellite internet or getting text messages on my phone, or any of the other myriad of space related benefits that me as an Earthling receive. I'm sure I would have some more appreciation for all the science and engineering that's going into it. Um, that's fantastic. Dave, thanks so much for your time. It's been a pleasure to speak with you. And again, it's fun to have this conversation and have it be a little bit full circle for me, where my OM journey really did start with my mom saying, "Hey, you should check out this thing. This other homeschool team has been enjoying it and done really well. You should think about joining this team that this other mom is putting together." And then, like I said, my first year, seeing you and your team compete, and I think I've seen the Renat Trafuska trophy at World Finals with East Chapel Hill homeschoolers on it, and so that's a huge accomplishment, and it's cool to hear you still be proud of that when you can be proud of a lot of other things as well in your career. So thanks again for taking the time to chat.
Yeah, this was wonderful. Thanks so much.